I have the pleasure to give the floor to Professor Alina Tenescu, a colleague from the University of Craiova, for the second plenary speech titled Perspectives on Machine Translation of Media Discourse. Please, Professor Tenescu.
So if we are to overcome linguistic and cultural barriers, I thought that this topic might interest young people and generation of students who train not only to be better translators, but also better intercultural communicators and mediators. So my paper or this presentation has to do with different perspectives on machine translation of discourse and texts from the domain of communication and the media. And oops, I hope that you can see the slides. Okay. So the current generation of students exhibits nowadays heightened responsiveness to blended learning paradigms, which strategically integrate traditional face-to-face instruction with computer-mediated and internet-based modalities. That is why hybrid approaches not only foster systematic development of digital literacies, but also enhance metalinguistic awareness and operational proficiency in digital tools, most notably machine translation technologies, amongst students who study language and translation. That is why this kind of blended learning has been shown to contribute to the consolidation of advanced textual competence with these students. The scope of this study is to evaluate the quality of some French to English, English to French, and Romanian to English translations generated through the automatic processing of media texts within our corpus of study by translation memory software such as Bing, Google Translate, and Sistran, using two established evaluation metrics such as SAE and BLEU. These are the only standardized evaluation metrics for the quality of translations, be it human or machine translated. A second objective of this study is to examine the most recurrent errors that appear in machine translation of these texts, as identified by students in translation, but also by specialists, following the automatic processing of English to French, French to English, Romanian to English by this translation memory applications Google Translate, Sistran, and Bing. The analysis will focus on the 7 primary errors that are committed with automated translation systems, such as terminology, semantic structure, spelling, punctuation, and completeness. And what we did with the first evaluation metric is to apply it in order to evaluate the quality of translations from English to French and French to English on the corpus of study, taking into account these 7 categories of primary errors. And what I have done is to translate the source text into the target language, which is either French or English, and then to apply a test that is named concordance test. And we retranslated the text resulted from the translation back to the source language, to the English or French text, in order to see if the result of the reintroduction of the translation within the same translation application will get a result as close as possible or as further as possible from the original text, from the source language. And the text T1, for example, is in English. It is translated into French with the help of GT or Sistran. and we obtain a text which is T2 in French. Then in a second phase, we introduce again the text resulted from the translation T2 within the same application, and we translate it back to English. And we apply the evaluation metrics, taking into account its 7 primary errors and the way that we can count these primary errors. But I would only like, before showing you how we count the primary errors, to start with this metaphor about translation. From Kumara Jiva, that asserted that translation nowadays resembles, in fact, to an already masticated food that will be given to him who cannot chew it himself. And automated translation would be then tantamount to victuals chewed by the mouth of an artificial organism, whose aim would be to guide the human operator in his work as validator, as post-checker, as verifier, of the linguistic solutions that are generated by the machine translators. With these approaches, we chose, because there are a lot of machine translation softwares nowadays. We know that Google Translate and DeepL and Sistran are amongst the most used machine translations online. We chose Google Translation because it is a statistical machine translation, and Sistran because it is another type of machine translation software. It is a hybrid one. And we wanted to see if the hybrid machine translation performs better than the statistical machine translation on the same corpus of study. Of course, if we were to compare the two, we also have to say that Google Translate has much more pairs of languages that get translated and enriched each year. So the main difference between SMT and hybrid machine translation is that the statistical machine translation uses automated translation that starts from statistical models to generate translations by analyzing large amounts of parallel text data from bilingual corpora in order to determine the most probable translation for a given text, whereas the hybrid machine translation takes elements or borrows elements from rule-based machine translation, SMT, and neural translation, and it is much more fluent. So now, going to the first evaluation metric, SAE, that dates back to the beginning of the 2000s, we can see that in order to weigh these 7 categories of primary errors, the evaluation metric distinguishes between a serious error and a minor error, then 2 meta rules that help evaluators in their decision in case of ambiguity, and then we have numeric weights for each category of error. For example, for a wrong term, we have a weight of 5 divided by 2, then for a syntactic error, 4 divided by 2, for an omission of a word that is omitted in the target language, 4 divided by 2, agreement error, 4 divided by 2, misspelling, 3 divided by 1, punctuation error, 2 divided by 1, and miscellaneous error, 3 divided by 1. And then we count the total amount of errors in the translation obtained from the memory translation machine, and then we divide it by the total number of words that is specific to the source text, and we obtain a score according to which the translation is better or worse. And for the corpus of study, which we have chosen different texts having to do with the media and information sciences. The first one, as you can see, T1, is translated from English to French. It's about information literacy nowadays. It is translated into French, then back from French into English. And we have here the T2, the result using Google Translate. Then we have T3, the reintroduction of the translated text within the same software application. Then we have the same English text translated but using Sistran, and then the reintroduction of the translated result within the same software application. And with the second text from French, translated from French to English, this one is about interactive media technologies, and we have done the same procedures, and we have obtained the following results. As you can see here, if we make a comparative analysis using the current version of Google Translate and Sistran, and we apply also the test of concordance, we obtain the following results. In figure 1, as you can see, when the source text is in English, a higher degree of accuracy in translation is achieved by Google Translate. This is also true for the test of concordance, when in the second phase we introduce the text T2 and we retranslate it to the same source language. When the text source is in French, we obtain opposite results. A higher degree of accuracy is achieved by the hybrid memory translation software, that is Sistran. Then if we go back, if we go to another category of errors made in translation, that is wrong terms, we draw the following conclusions. When the source paragraph is in English, we encounter many more errors committed by Sistran than by Google Translate. Then if we go to another category of errors that you can see here, we noticed that with the wrong terms category, we remark fewer wrong terms with Google Translate than with Sistran when we reintroduce the result of the paragraph translated from English to French in the same software application. If we go to another category, if we go to the last category, as I said, the category of syntactic errors, when the source paragraph is in English, Sistran is better than Google Translate. But when we reintroduce the paragraph T2 in the same memory translation application, Google Translate, and we retranslate them into English, we obtain a higher accuracy with Google Translate than with Sistran. If we want to also underline the weaknesses, the weak points of these machine translation softwares, we observe that we get, for example, similar scores for the weight of morphological errors for both Google Translate and Sistran. And the weakness of the automated translation provided by the hybrid software, that is by Sistran, consists in the fact that it records more wrong terms than Google Translate, inclusively at the test of concordance. So by comparison with Sistran, Google Translate counts higher scores, while it weighs the burden of more syntactic errors. And it is something interesting to notice that if we also make a comparison between the hybrid machine translation and the statistical machine translation, in general, the statistical machine translation will make many more grammar errors, whereas the hybrid machine translation will not be able to decode or to translate idiomatic expressions at all. Going to the second evaluation metric that was named bleu, from the color blue, here we have another pedagogical tool that could be used by students in translation in order to evaluate the quality of automated translation. And we can start from this path that is proposed by Anna Nino to students in foreign languages and translation, and who talks about the pedagogical method of automated translation taken as a bed model on which students can work in order to improve the result, the translation, and to post-edit it. This evaluation metric, as you can see here, counts the word error rate, making a comparison between the source text and the target text. The target text can be a translation that is supplied by an automated software, and that can be compared to the same translation that is proposed by professional translators. And you can see that for this bilingual evaluation understudy, in order to evaluate the quality of translation, we will associate a weight equal to all the n-grams. So we will compare the number of words that are present in the source text and the same words or the number of words in the target text that are the same as within the source text. According to Clau, students and sword translators can manipulate the weight and the values and the sentence brevity penalty, because sometimes, as we can notice, the translation that are generated will contain fewer words than the source text. And we have chosen for exemplification a paragraph on telecommunications from the book Comunicarea by Mihai Dinu, a professor from the University of Bucharest, and we have compared the results of translation of this paragraph by Google Translate and Bing with two references represented by human translations into English, provided by two English professors from the University of Craiova. And what we notice is that we have here the source text in Romanian from Mihai Dinu that counts 40 words. We have the candidate one, here the translation into English done by Google Translate, the translation into English done by Bing, and the references proposed by the two teachers from the University of Craiova. And we will compare the candidates with the references 1 and 2 and the source text in Romanian. And what we get with this evaluation metrics is the following results. So candidate 1, as you can observe, counts 31 words, of which 24 are found in the references. In reference 1 and reference 2 proposed by the professional translators. So the translation candidate 1 will thus receive a weight or a unigram precision that represents the division of the number of words that are found on the reference texts to the total of words in the initial translation done by the machine translation Google Translate. And if you can see that it is a score close to 1, it's 0.77, a good score in spite of the fact that the result of the translation performed by the hybrid machine does not retain much of the contents of reference translations 1 and 2. Whereas candidate 2 comprises 39 words, of which 32 are found in the reference translations, and we will assign a unigram precision of P, represented by 32 divided by 39, 0.8. That is to say that the scores or the comparison of these scores attributed to the unigram precision of the two automated translation reveal a better performance for the hybrid machine translation software Bing, whereas Google Translate, the statistical software does worse. Okay, so here you can see how we can count the unigram precision as well as the modified unigram precision for each word in the candidate translation proposed by the automated machine software. The algorithm helps us to calculate the maximum total count in all the reference translations. And then, for example, in our corpus of study, a word like television appears one in reference 1 and once in reference 2. So the maximum count would be 1. And for the candidate translation 1, the count MW of which word is related to the words MMax. And thus we obtained the modified unigram precision and the scores for the two candidates. The conclusion is that using this second evaluation metric for the quality of automated translation, the comparison of candidate translation with reference to translations in English allows us to measure the accuracy, the fluency, and the fidelity of results obtained from the optimized processing of the source text in Romanian by Bing and Google Translate. And we observed that these obtained scores using the second evaluation metric BLEU shows us that automated translations are at least 30% worse than human translations. And we think, or we are convinced, that these operations of translation and the passage from French to English, from Romanian to English, from English to French, as well as the use of these two evaluation metrics, provide a model or an analysis guide which could be useful for students in translation as well as for professional translators, since it gives them the possibility to develop their analytic thinking and to carry out researches on the existing differences between translation memories nowadays, as well as on the weaknesses and strengths of each of the translation softwares, as well as on the degree of precision and quality of translations provided by each translation engine. And of course, if we were to try and do this operation with the use of ChatGPT, we wouldn't be able to do it because with SAE, the first evaluation metric, we can only do the manual evaluation of these translations. Thank you.
Thank you, Alina, for presenting